Hello Year 10. Today's lesson is a revision lesson. We're going to look back over some work we did on electricity earlier in the year. So please listen carefully. You might want to make some notes as we go through this. There will be a mini quiz on its learning for you to try at the end of this. So let's look forward to the next lesson. Now I quite like this picture. Shows a grumpy old man down there in the corner. I kind of relate to this grumpy old man. He's at a child's party. Somebody's sticking balloons next to him. He doesn't look very happy, does he? But the physics here is interesting because how can we make a balloon stick to the wall? Okay, you know that when you rub a balloon, if you rub a balloon on your hair and you stick it on the wall, it becomes charged up. And there's a bit of static and it sticks to the wall. How does that work? Well, before we explain that, let's just recap the basic, what we mean by charge, some basic facts about charge. So there are two types of charge, negative and positive. There is also neutral charges, and that's where you've got an equal number of positive and negatives and they cancel each other out. So really there's just two, positive and negative, but if there's an equal number, they cancel each other out and we get neutral charge. The negative charges we call electrons. The positive charges are called protons, or sometimes we call them ions. Okay, so I'll just write that in there. You get positive ions. You can get negative ions in chemistry as well. If the two charges are opposite each other, they attract. So what you can see here is a positive and a negative. They're oppositely charged, so they attract. Whereas if things are the same charge, like here, so you've got two pluses repel each other, and also two negatives repel each other. Okay, so you need to make a note of that. This is the basics of charge. Okay. So the effects of charge, I think we may have seen some of these in the lesson. We can make balloons stick to the wall. After you've combed your hair several times, it's actually possible to pick up bits of paper with your comb because it's become charged. You may have seen the Van de Graaff generator down here. So this girl she's put her hand on the Van de Graaff generator, and that's made all of her hair stand up. And also lightning. Lightning is to do with charge as well. So all of these phenomena are to do with electrostatic charging. Now, what we mustn't get confused with here is when we talk about charging our phone. That's a bit different. It's not really electrostatics. So what we are looking at in today's revision lesson is electrostatic charges. Okay, let's move on to the next. So how can we make a balloon stick to the wall? Well, let's read through this. Okay, I might need to make a few extra little notes to clarify as we go. So a normal balloon has zero charge. Now by zero charge we mean neutral, because the negative charges are exactly balanced by the positive charges. The balloon is neutral. So in here, this balloon at the top here, let's count how many negatives and positives there are. So I've got 1, 2, 3, 4, 5, 6. Let's make that in black. I've got 6 negative charges. I've got 1, 2, 3, 4. I've got 6 positive charges. So it's neutral because they cancel each other out. Okay. Move on to the next paragraph. When the balloon is rubbed on someone's hair, the negative charges are rubbed off the hair. So all of the negative charges have come off and they have gone onto that boy's hair. Okay, the negative charges are rubbed off onto the hair, leaving the balloon with just positive charge. The balloon is no longer electrically neutral. Okay, so when you rub something, you actually can rub the electrons on or off. Look at the next one. The balloon will now pick up small bits of paper there is an electrostatic force. Now that's important, remember that. There is an electrostatic force which attracts charges together. The negative charges in the bits of paper are attracted to the positive charge in the balloon. The name of the force is the electrostatic force. Let's make sure that we know that. Electrostatic force. Okay, we'll ask you about that in the quiz. If the charged balloon is brought near to a wall, the balloon will stick to it. The negative charges in the wall, I'm going to highlight those, these negative charges here, look, are attracted to the positive charges in the balloon. An electrostatic force holds the balloon to the wall. The total charge in the wall is neutral. So let's have a look at the wall. We have got in the wall 6 negatives and we have got 6 positive charges. So the wall is neutral. Wall is neutral. Okay, but the negative charges move towards the balloon. Okay, right, let's move on. So we can also charge up plastic rods, and this one is polythene. Okay, this is polythene. When we rub a polythene rod, polythene is a type of plastic, with a cloth, electrons go from the cloth onto the rod. Okay, the rod becomes negative and the cloth becomes positive. Now compare that to a perspex rod. It's a different type of plastic. This time we're rubbing the perspex rod, but the electrons move the other way. Electrons go from the rod onto the cloth. So the rod becomes positive and the cloth becomes negative. So the electrons are the ones that move. So we need to say this: only electrons can move. Okay, so but it depends which way the electrons go. Okay, so let's move on. This thing is called a gold leaf electroscope. What it does, it detects charge. If you bring a charged object near the disc at the top here, if you bring something charged near it, you don't even have to touch it, these gold leaves down the bottom here separate. So the example that we've got on the right hand side, we've got a positive charge is brought near the disc and the gold leaf separates at the bottom. Now this works just as well with a negatively charged object as well. Okay, so that's called a gold leaf electroscope. It's used for detecting charge. Okay, let's move on. Now charges can move. Okay, and this is now where we're coming on to current electricity. This is no longer static, this is moving. And what you can see here is that the negative electrons, they can flow from one atom to the next. So these electrons have the ability, okay, to sort of jump from one atom to the next like that. And that is a current. And the electrons can do this in metals because they are what we call free electrons. Okay, they're called free electrons because they can jump from one atom to the next. Sometimes they are called delocalized. It means the same thing. The electrons can jump from one atom to the next. They're free to move. And this is what we call an electric current. Okay, let's move on. So how do we make electrons? How do we push them along a wire? Okay, the wire is made of metal. It has free electrons in it. So metals have free electrons. So they make good conductors. Now we use a battery here, or a cell, or a battery, and it pushes the electrons. Okay, so electrons get pushed that way, and the electrons go this way. Some of them go down here, and then at the bottom here they go back towards the battery again. Okay, so a battery is used to push electrons along the wire. The electrons are repelled away from the negative terminal and attracted to the positive terminal. Okay, so we can make electrons move around a circuit using a battery. Okay, let's move on. There are some videos here that I'll put this PowerPoint into It's Learning. You can click on those if you like, and you can have a look at those. So how do we measure charge? Okay, because you can have lots and lots of charge in one place. Charge is given the symbol Q. It's a bit strange, but Q is the letter we use for it. We can't use C. C is used for other things. The unit of charge is the coulomb, okay, and that does have the symbol C. Current is given the letter I. It's measured in amperes, capital A. Time is, we use T, don't we, to represent time. It has the units of seconds, or just S. Okay, so you do need to learn all of these. Now we can link current, charge, and time together. This is one of those important equations in physics that you need to learn. I will be putting a few basic questions on this in a quiz for you in It's Learning. The definition of current is the rate of flow of charge. Again, you should learn it. Learn this. Current is the rate of flow of charge. I equals Q divided by T. So current equals charge divided by time. I'm going to write that at the bottom. Okay, current equals charge divided by time. So 1 amp of current flows when 1 coulomb of charge flows by in 1 second. Okay, have a look at these examples here. Calculate the charge. So we're going to use Q equals I times T. Remember that Q is charge, so Q equals the current, which is 20 times 12, 240 coulombs. Okay, question 2. How long does it take, I'm going to work out the time, for 3 coulombs of charge to pass through a battery supplying a current of 0.5 amps? So we want to have T equals, well, T equals Q divided by A. The charge is 3 coulombs. The current was 0.5 amps. So the time is 6 seconds. Okay. There is a triangle that you can use to help rearrange this equation. Q equals I times T. Look at the last one. 2.5 coulombs of charge flows through a lamp in 3 minutes. Calculate the current. So we want I equals Q over T. Okay. Now T is in minutes here, but we want seconds. So 3 minutes is multiplied by 60 is 180 seconds. So going back then, we've got the charge is 2.5 coulombs divided by 180 seconds. Okay, I'm just going to get my calculator out there. 2.5 divided by 180, okay, is 0.14 if I round that up. So 0.014 seconds. Okay, that should be a 1 there. I've rounded that up a little bit. So you need to practice using this equation and rearranging it. Okay, let's fill in these missing words. Okay, so again, you might get a paragraph on the It's Learning page, and you have to fill in the missing words, so make sure you can do this. Electricity is a flow of electrons moving through a conducting material like copper or graphite. Metals are good conductors because there are many delocalized or free electrons that can move freely from one metal ion to the next. there are many millions of electrons in a short piece of conductor. Each electron has a negative charge. Charge is measured in coulombs, and 1 coulomb contains 6.25 million trillion electrons. If 1 coulomb of charge passes a point in the circuit in 1 second, then there is a current of 1 ampere flowing. Okay, so take your time with that one, read it again, you can replay the video. A basic circuit requires a battery or a cell joined in a conducting loop with a component like a lamp. The battery does work on the electrons, which gives them energy to carry around the circuit. When the electrons get to a component like a lamp, they transfer some energy to it. A lamp will convert this electrical energy into light and heat energy. Electrons move from negative to positive. The electrons are repelled away from the negative side of the battery and are attracted towards the positive side of the battery. However, conventional current is said to flow in the opposite direction from positive to negative. Should be a little Y in there. Okay, so I'm going to put some of these paragraphs onto It's Learning. You're going to have to choose the right words. Okay, so make sure that you listen carefully. Okay, this is a series circuit because it only has one path for the electricity to flow. Okay, so it's going to come out of the, that's the positive side of the battery, that's the negative side of the battery. So the electrons are going to move this way around. Okay, that's the way that the electrons are going to go. But of course the current goes the other way. Okay, now we've got 4 ammeters in this circuit, here, 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 and here. The current in a series circuit is the same everywhere. So if let's say we had 0.5 amps there, well, I must have 0.5 amps there as well, and 0.5 there, and 0.5 there. The current does not get used up. It's the same everywhere in a series circuit. Okay, let's move on. If we increase the current, okay, well, what we're doing here is we're making a bigger and bigger battery. Can you see that? I've got 1 cell there, 2 volts, got 2 cells there for 4 volts, 3 cells here for 6 volts. That's going to push more and more current around the circuit. So let's say that we had 0.5 in this one. I would have 1 here, that's amps, and I would have 1.5 here. Okay, if I increase the voltage, I also increase the current. Okay, let's move on. Now, these were the results of an experiment that we would have done in class, but we're not going to have time for that. So, conclusion. The current is the same at every point in a series circuit. The current increases when there is a greater potential difference or voltage. Another word for potential difference, remember, is voltage. The current decreases when there are more lamps in the circuit. Okay, right. I think that's the end. Let's see what else we've got. Oh, we've got models of electricity here. These are quite fun. So, different ways of thinking about electricity. We've got a burger bar. We've got some men walking. They're doing some work down here. So they're doing work down here. This is equivalent to, okay, the burger bar is like the battery. That's where they get their energy from. Okay, the men are walking around here. Okay, so the men represent charges or electrons. Okay, and they're doing some work down here. So this represents something like a lamp or a motor. Okay, so we can think of electrons as going to a battery, collecting energy. They then carry the energy and then they transfer it, they do some work. Okay, let's look at the next one. Right, let's look at the next one. So this is model number 2. We've got a coal mine. Now this is where the energy is coming from, and the factory is where work is done. So that's a bit like the lamp, and this is a bit like the battery. We have got a current moving. Each truck is like a charge or an electron, and the coal is energy. Okay, so we can look at. Okay, this is the last slide now. These are circuit symbols that we use. You must learn these. I'm going to test you on these in the mini quiz I'm going to put together for you. Okay, so make sure that you have a good look at these, practice drawing them, practice naming them, and I'm going to test you on it in its learning. So thank you for listening. Replay the video again if you need to, and please attempt the mini quiz in its learning. Good luck. Thank you.